welcome to all of you to our TECHtalk studio. And since I'm doing it in English, it's because I have a French guest, Emmanuel from the company Schaltbau. Schaltbau, which we have in Wexøe been representing for several years, with a focus on primarily what we call rolling stock within the train industry. But having said that, it's also so that they are specialists in switching DC, in DC contactors. And that is what we're going to talk about today, huh, Emmanuel? Yep. And why is that so a hot topic, or why is that certainly so actual with DC? Because I was educated back in 80s, and I was actually talking DC motors to the teacher at that time, and then I've not been talking DC since that. So why is it suddenly so very actual to talk about DC switching?
It's mainly due to the increasing demand of power for battery and with electrical vehicles, charging vehicles, battery energy storage. All these things are mainly DC supplied. So, and we need more and more energy and on the DC base.
So what we can do is in designing DC contactors to a variety of applications, depending on the voltage and depending on the
current.
Other currents. Yeah. And from what is the range that we are able to deliver?
At Schaltbau, we go. We are experienced with the rail business, so we are familiar with voltage up to 3 kV, and with current up to 2 kiloamp. So
2 kiloamp.
2000.
Okay.
Yes. And of course, you have different kind of supply. You can have inductive load, different kind of loads, the inductive load, resistive load, etc. And and for railways, it was mainly inductive load. So you had strong and big contactors, while in the BESS or EV vehicles, electrical vehicles or EV chargers, you don't need this huge inductive loads, so you can have smaller products.
Okay.
And so we developed some products for this specific industry, taking our experience from the rail.
When you're saying BESS, I guess it's battery storage?
Yes.
Okay. So where do you build in the contactor? Is that in a panel, or is it in a product, or how do you see where? I'm just wondering. Yeah. So when you talk about 2,000 amp, I'm looking at a bastard like this. Where do you build in the contactors?
Yeah, the contactors are. Yeah, you have different sizes for the same for the same current, but it's mainly due to the load you will face.
It will decide the footprint of the contactor, yes. How big the load is.
Yes, because the fact is with DC, and the challenge is that you never, compared with AC, you never go through the 0 volt.
No.
So when you open, so the DC current is always at a certain voltage, and so you often open under load or with no load, but with the same voltage.
Yeah.
And the problem is that the voltage generates the arc.
Yeah.
Because insulation distance is not guaranteed anymore. So.
And how do we protect the surroundings for the arc? What is the concept behind your contactor?
Yeah, we
just in brief, without deep diving.
In brief, what we do is generally we let the arc express itself. So when we open the contact, the insulation distance is not enough. So the arc is generating, and so we let the arc happening, and we generate an electromagnetic field in order to send the arc in the right direction where we want it to go within the contactor.
So you're using magnetism to send the arc in a certain direction?
In a certain direction.
All right.
Away from the coil.
Yeah.
Not to destroy
so you don't hurt the coil?
Yeah. Yes. And we send it in a direction where we have some splitter plates. So the longer the arc will get, the weaker it will get. It will get cooler, and then it will reaching splitter plates where it will be divided in small arcs, and then it will die by itself and will be cooled down also by the vents that are on our contactor.
So no heating either? Limited?
Well,
limited.
Limited, but because the arc is very, very hot, it's about 20,000 Kelvin,
Yeah.
but for a short time.
Yeah.
But due to the vent, because we use open air technology, so we have the ambient air that is going through the contactors. So the arc is so small, temperature is so high,
Yeah.
that it will get cooled down very, very quickly compared to some other solutions where the arc is captured in a cell and you can't cool down really. So the heat will remain inside and the pressure will be generated. So, yeah.
If I'm a Danish customer that want to use a DC contactor from Schaltbau, what kind of basic information do we need to calculate or to evaluate the right contactor to the right application? What kind of basic info do we need?
First, you need to know the voltage you have, because this will define a bit the size due to the insulation distance and creepage distance. Then, of course, the power or the current,
Switching current.
the current you will have, and also the time it will last. Because if you carry current for 8 hours or for a few seconds, you won't have the same, you won't have, in few seconds, you won't have the time to hit the contact as much as within the time. So when we define the nominal current for our contactors, for example, 500 amp, this value is named because we make the contactor to withstand 500 current for at least 8 hours. So we measure for 8 hours, and after 8 hours, generally the temperature of the contact gets stabilized.
Yeah.
So you don't have to worry anymore. So it will be constant, and you can define the nominal value.
So voltage, nominal current.
Yes.
Maybe also physical footprint. What do you have available?
Yes.
And number of switches, I guess, also. Huh? Number of operations, or is that a thing?
Yeah, the number of operations. So we have the mechanical operation. If you make, because sometimes in general with new application for battery storage systems or this kind of application, you will not break under load. You will generate, so the voltage will be there, but the power will be dropped down, and then you can disconnect. But you are never sure that there is no incident that occurs that make you switch under load. So you have to pay attention. If you need to consider that sometimes you may break under load and you want your contactor to resist that, or if you need to break the load regularly.
Yeah.
And so the amount of load breaking. So this
is obviously important.
Yes.
For the dimensioning. So is a standard product, in the range you have that standard, or is it customized?
We have, for ADC product, we tend to go for standard products.
Yeah.
So we have a range which is quite standard because with the industry, we need to be price competitive.
Yeah.
In railway, it's quite different. We need to be price competitive, but in railways, it's quite different because the volume for a project in railway are quite small. When you have a project for 100 train, it's a huge project. Yeah. But 100 train, if you have 2 contactors per train, it's only 200 contactors. So of course you have to pay R&D and to cover the cost of the 200 pieces. So the price can get very high.
But I think the applications you mentioned in the beginning, battery storage, electric vehicles, whether it's cars or trucks or whatever. Yeah, there's a lot of things that's already doing out there in the marketplace. Huh?
Yeah, sure. Then in that case, we make some forecast on the volumes. Yeah, and we have high expectations in terms of volume in order to reduce the price over the complete serial production. Yeah. So and then we can make savings and be in coherence with the market price. So.
Out of curiosity, I guess a contactor is like an old-fashioned contactor with a coil and switch, and then of course the arc chamber. Yeah. So there's nothing electronic into a contactor. It's more or less copper and iron, or what?
In theory, yes. In the contactor himself, it's basically a coil and a contact, and you make the switching. Then, if you want to make some savings in terms of power dissipation, you need to focus really on your contact to get the lower resistance possible, so that you have less power dissipation, and then you can save on the energy. You can make energy saving. So when you sell, for example, power to charge a vehicle, you don't want the energy to transform into heat. You prefer to keep the energy to send to the car and to sell it.
Yeah.
So this is one topic. So this is really on the main contact itself. Okay. Then also on the coil, there are ways to make sure that because with DC, we need to open very fast when you open. So you need a strong spring, so you need a strong coil. And a strong coil means high energy to switch the contact. Yeah. And high energy means a lot of current. And the current, you need it only in the beginning. And then to hold the contactor, you don't need so much current anymore. So what we do, we check the contactor. We send a lot of power in the beginning. Then after a few milliseconds, we release a bit the power to maintain the coil. And we check also then temperature, some parameters around the contactor to make sure that the pressure is sufficient to have the sufficient pressure to have a low resistance and to save on power dissipation.
So that's done by sensors or
some sensors and electric boards within the contactor.
Where do you manufacture the DC contactors?
We have different plants
around
from the group, and mainly the contactors we manufacture and we provide for ADC are made in Germany, close to Munich, close to our headquarters in Velten. Yeah, brand new zero carbon plant, and also to one of our subsidiaries in Wales.
Okay. So since you're mention zero carbon plant, I have the last question for you. And then will be a tricky one. Your product. Can you document also the CO2 footprint of a product over the lifetime?
This is something we have to work on, but
it's a work in progress.
It's a work in progress. Yeah,
okay.
we make effort on the plant to reduce our footprint, and of course we are concerned with with energy saving, and this is why our products also are really focusing to have a total cost of ownership as low as possible, and if we consume less energy to be competitive, to have a low TCO, then we are green.
I fully buy into that. Yeah. If you're in your R&D already had developed a product with a low TCO, I mean, that's down my alley. Yeah. But the other thing is actually also fulfilling CSRD, and since the applications are green, EV, battery storage, you will probably meet a demand from our angle of the world that, hey, you need to document your CO2 footprint per product in a lifetime of the product. In the long run, you need to be able to document that.
We will have to do it, but it's a long process, a paperwork process to be done. But anyway, we will have to do it.
Yes.
So,
Emmanuel, thanks a lot for joining the Tech Talk. If you, sorry, nu switcher jeg lige til dansk. Hvis nogen af jer ønsker mere content af den her type, så skal I trykke på subscribe-button nede under. Det er også sådan, at inden vi gik i studiet her, der har Emmanuel lavet et webinar med min kollega Lars Flyvering. Og det har vi optaget. Vi har broadcastet det direkte, men vi har også optaget det, og vi tænker, at vi lægger på vores hjemmeside, så I kan se mere omkring DC-switching. Hvis I ellers har spørgsmål, eller gerne vil i dialog omkring InDesign og applikationerne, så ringer I til Lars Flyvering. Jeg sørger for at sætte hans nummer et eller andet sted på skærmen med os. Så ringer I bare til ham. Han trænger til noget at lave. Så slå på tråden, og tak fordi I var med på den her. Tak.